Welcome back everyone to the Hello World guide. This is another episode of the Asteroids game in C++ series, and in this video we are gonna continue by implementing a method to intersect our asteroids with our player. So currently our asteroids do not intersect with the player and they do not intersect with each other, so that is not exactly what we want, and we want a way to make the asteroids intersect with the player as well as other asteroids so that they don't do that. So you can see the player can pass through the asteroids, and if the asteroids collide with each other, nothing happens at all. The first thing that we are gonna do is implement actual algorithm for intersecting two different polygons. Now since we are developing a complex kind of algorithm, even though it's like we are basically going to just write the code for it, it's better to test it alone, standalone, separately, and then implement it inside of the game. So for this I'm going to actually comment these lines in which we are doing the game, and here we are going to create a simple driver program which will allow us to actually draw two polygons, and then we'll run our physics algorithm on that, and if it works then we'll incorporate in the game. So first of all, let's create the basic test or driver program. Now as I said, our driver program is allow the user to draw two polygons. So for that we are going to have two vertex arrays representing poly 1, which will be an SF line strip, and poly 2, which will also be an SF line strip, of course, like all polygons in our asteroid and player. So with those we will now go ahead in the main. We will actually first of all go ahead and create an enum. We'll create it directly here, don't need to declare it, which will have three conditions. Either it will represent our state, either we are drawing poly 1 or we are drawing our polygon 2, or we are testing the polygons whether they intersect or not, and by default we are going to start with drawing poly 1, and we don't need to, you can see we can create an enum directly like this. Now we are going to go down here where we are doing our events, and we are going to check if the event type is a mouse button pressed event instead. If that's the case, we are also going to make sure that the button that's pressed was the left mouse button, and we can get it quite easily using this. And if that's the case, we will create an SF vector 2f called position, which will set to the mouse get position window. We need to pass in the window as the argument so that we get the position relative to that. And secondly, we want to convert it to SF vector 2f. We want to use a cast for that, because by default, as you can see, this returns a vector 2i, not a vector 2f, so we need to do this. Afterwards we can go ahead and check if our state is polygon 1. If that's the case, we'll say polygon 1 dot append, and we'll append the SF vertex. We'll create a new vertex with the position, and for the color we'll just choose white. So we'll do that. We'll create an SF vertex, and the position of the vertex is going to be equal to the mouse position, while the color is going to be white. Now for if the state is polygon 2, we are going to do similar thing but for poly 2. Now if the mouse button event was not pressed, then we are going to check for the event of the keyboard button pressed, and we are going to check if the space key was pressed. The space key will use to we need to check e.key.code, by the way, here, not just key. This space key will signify that we need to move our state to the next one. So if our state is equal to poly 1, we'll just set it to polygon 2, and if it is polygon 2, then we'll set it to polygon 1. Like we'll actually set it to test, not polygon 1, and if none of those conditions is true, we'll set our state to polygon 1 here. Now of course we want to ensure that we draw our two polygons, so window to draw poly 1 and poly 2, and we also need to well, that works, but there are a couple of things remaining here. So first of all, I'm going to go here and say poly 1 dot append, and we are going to basically make a copy of the polygon's first vertex and append it to the end of it. This ensures that the polygon is now closed, because by default a line strip is not closed, so we close it by essentially duplicating the first vertex. Of course this means we need to ensure that the vertex count is actually greater than 0 for both of these, and we need to do the append for both of these as well. And since this condition might fail, we want to actually put the last condition and else if as well to check. Well, actually before we do that, we are going to also make sure we clear whenever we get out of the test condition. We are going to clear this so that the user can draw again if the user wants to do that, and we are going to check if the state is test here, and of course we want to make sure that we actually clear the window before drawing everything. So with that, yeah, that means we have got our smallish driver program ready. So we are going to go ahead and say run, and once we run that, what you should see is that I am able to currently get an empty screen. If I press here like that, I can make a shape and I can press space and it will automatically close the shape, and I can draw another one here now, and then I can press space and now I cannot draw if I click, and then I press space again and it clears the screen and gets ready for the next drawing. So yeah, you can see that that is working quite well. And this is our basic driver program. Now for the actual function, we'll create a copy of the intersect function here, like that. Actually, let me paste this. So we'll just copy the intersect function and then paste it here. We are going to create an overload of the intersect function, but of course this is going to take both arguments as vector, not vector 2s, as vertex arrays. This will be called poly1 and this will be called poly2. Alright, with that we have got this implementation as well. Currently we are not going to implement it just yet. Instead, whenever we switch to the state of test, we are going to check if physics, well actually we need to include physics.h here for that, so we'll just go up here and include physics.h. So include physics.h. Now what we will do is we'll go down here and we'll say if, and we'll say physics colon intersects, and we'll use the overload that requires 2 polygons, so we'll pass in poly1 and poly2. Now if they do intersect, then we are going to basically we can just print to the standard output. We can use printf, or you can also use stdcout if you want to do it that way. We are going to say intersect. And if that is not the case, then we are going to say not intersect. So if that's not the case, we'll just say printf do not intersect, and this will basically output it as a text format every time we are done drawing the figures. And of course this program will currently not actually compile because we have not implemented the intersect function, and that is what we will do in the next video. We will implement the intersect function. Currently we are going to create just a dummy intersection just to test stuff up. Well, it seems to have failed. Let me open this up. Yeah, it has actually created the overload here. So if I run this, you can see that I can create a shape and then press space, and I can create another shape and then press space, and this says do not intersect because by default our function is returning false for everything, and if it were to return true for everything, it would say intersect. Now of course we are going to in the next video actually implement this function and implement the algorithm to find out whether the polygons intersect and see whether it works, and if it does, then we are going to go ahead and implement it inside of our game. So yeah, that's going to be pretty awesome, so stay tuned for that and make sure to like and subscribe so you don't miss that one. I'll see you in the next one. Make sure to share this video with other people as well, and bye.